Yeah, I'm going to be talking about sort of software supply chain security and the open source security sandwich before lunch. Hopefully get you nice and ready for lunch. Okay, a little bit about myself. Okay, so I'm the co-founder and CTO of Kusari, a software supply chain security company. Before I was there, I was doing a whole lot of work in sort of fintech and banking and a couple other places like that. I'm also one of the co-authors of a book called Securing the Software Supply Chain, which if you want a free copy, feel free to scan that QR code and you can get yourself a free copy to that book. That's co-authored by Brendan Lum from Google and edited by Ben Cotton. And I'm also heavily involved in open source. I am an OpenSSF Technical Advisory Council member. I'm also a governing board member. I am a CNCF TAG Security Tech Lead. And I'm maintainer of GUAC and SLSA and various other open source things. Cool. All right, the problem, right? Security can often feel like a dumpster fire, right? Why does it always seem like everything is on fire? Let's go, last year, what was the big thing? Hey, XZ utils, right? There seems to be a new backdoor, a new vulnerability discovered seemingly at least, once a month, once every other month. March of last year, there was the XZ incident, which was a malicious actor, most likely state-sponsored, came in, injected malicious code into the actual repo, had modified some of the build so that when the actual when XZ was being built as part of OpenSSH, it would have a massive backdoor that would allow a certain attacker to be able to get into various other, various servers. We also had stuff like, folks remember polyfill from last year as well. We have stuff like that where somebody malicious was able to hijack sort of polyfill and update that, and then leading to everything downstream, downloading the vulnerable dependency. And so here is just as of, I don't know, about a half hour ago, the latest vulnerabilities that were listed from the GitHub service advisories, right? Just today, here, as you can see here, most of them are just from this morning, right? Only one from yesterday. And so I don't even know what any of those are right now, but like it's constantly going on and on and on. And so you might be tracking, like, do you actually know whether or not you're actually using any of those? Are you sure? I'm not sure. And how do you know that your dependencies are not using those things? So let's take a step back, right? What is supply chain security really, right? So this is just sort of my definition, but I believe it to be a pretty accurate one, which is like software supply chain security is just the act of securing the production and consumption of software. In other words, it's about securing the SDLC. So if you're, if you are consuming, if you're producing software, you're part of somebody else's supply chain. And if you're consuming software, you are pulling things into your supply chain. And the security, security around it is just making sure you're not pulling anything vulnerable, nothing malicious, that kind of a thing. I'm not sure if any of you are super aware of SLSA or the SLSA framework, but that's a project underneath the OpenSSF. It's essentially a bunch of best practices around providing provenance around software. So for example, how do we, track that the source code is what actually ended up in the build? Because again, these are things like if you go back to the XZ utils, if you go back to good example, SolarWinds, everybody remember that one. Various pieces of that various pieces of the SDLC were compromised, which then led to the ability to actually compromise the binary and so on. And so Each one of those letters there is a potential area of attack, right? And we'll kind of go into what each of those is in a second here, right? So again, if I go in, each one of those things from producer, source, build, distribution, consumer, and the various dependencies can all be areas of attack. And again, so producer, right? The developer can be malicious, right? XZ. Take that as an example. Authoring and reviewing, right? Mistakes can be made. Do folks remember the OpenSSH regression attack? This was I want to say 15 years ago, probably 20 years ago almost, where, hey, somebody in trying to fix some stuff inadvertently made it so that OpenSSH was mostly like you only had a handful of keys that you needed to sort of iterate through, as opposed to, you know, some massive number. You have source code management, right? Your source forge can be actually compromised through stuff like, you know, remember the code attack. Your external build parameters, right, can be attacked, right, which is like, you know, malicious or insecure inputs for the build. So this is the Debian OpenSSL bug that led to sort of OpenSSL being compromised. Also, I believe that was 15, 20 years ago. You have the build process, right? The build process itself can be compromised. Think SolarWinds, where most likely state-sponsored actor was able to actually compromise the build system itself so that everything looked like it was running normally, and actually you were constantly injecting at the very last bit a DLL that was malicious. And again, at that point, they already have your keys for signing, so they were able to sign it. It looked legit. Artifact publication, right? We have how many times, like it seems like every day there's yet another NPM package that it turns out is mining crypto. Or just somebody is able to steal somebody's credentials to publish, which then allows them to sort of publish yet another crypto miner. Or something to steal your Bitcoin wallets. You have various distribution channel attacks, right? So back in the day, Ruby Gems was actually compromised, which through some tooling on Ruby Gems itself, allowing for anybody to publish malicious software to Ruby Gems without really any checks. And then also package selection, right? You know, when you're actually pulling down the thing, did I type in request or requests? Right, that was a common issue from a few years back, where I believe it's actually requests is the Python library, and some folks put in request. Somebody had said, great, I see that. I'm going to make something that looks very similar to the actual request library, type request, and then all of a sudden everybody's downloading malicious software. And it's also all recursive, right? It's not just about what you're currently including, but it's also what are the things you're using that are they protecting themselves? So if I'm using, I don't know, OpenSSH, and OpenSSH is using XZ, do I need to be aware of that? That's kind of a big issue as well. And it's turtles all the way down, as they say, right? It's not enough just to fix the problem in your software. You need to also, it's about the software your software uses. And the problem is not just in the software, it's in the hardware. It's often also outside of your control, because you're dealing with systems like PyPI and Maven Central. And how do you know everybody is doing the right thing? Now, like Maven Central, right, is backed by a commercial enterprise. They have a lot to lose, but a lot of folks are nonprofits. And how do you know that they're actually doing the right stuff there as well? And it seems like there's a lot to keep track of. This is super simplified, right? It's probably would look 20 or 30 layers deep. It'd be impossible to see. One time I ran I don't have it up here because it's just way too large, but one time I actually ran the full sort of dependency of Kubernetes, including all of the operating system level dependencies and all the things that are required to build Go, right? How do you know that the compiler you're using is correct? How do you know that the compiler was using is correct? And so all of these things are things that you should be keeping track of, but are obviously very, very difficult. It's not all bad. It's not all doom and gloom. There's been a lot of work in bringing sort of order to all the chaos in the open source community. There's been a bunch of white papers. There's books being written about this on how to start dealing with sort of supply chain security. There's also tons of tools being developed in the space, and we'll explore some of those in just a little bit. In addition, we're seeing work in the community, industry, and in government as well. And, you know, for example, the CRA, for folks who are been hearing a lot about that this week. And okay, so how do we get started with this, right? We could sit here for days talking about all the approaches and potential solutions to all the supply chain security problems we have. We don't have days, so let's look at a couple of common, easy ones. It's just regular security, right? Don't treat it any differently. You can apply the same practices you do to runtime as you do to supply chain security. You know, threat model, determine, you know, important assets and risks, design controls around those risks, and implement those controls. And also, it's going to be very different, right? If I am building my personal blog, I'll have a very different approach to software supply chain security than if I'm building out an online banking application. If I'm doing, you know, my personal blog, I'll take reasonable precautions, but I don't have millions or billions of dollars at stake for my personal blog. I just have a little bit of my reputation. Still want to be able to do the right things, but I'm probably going to be using open source. I'm going to be using free tools. I'm going to be using GitHub Actions. I'm going to be using all the great stuff from OpenSSF, CNCF, the LF, Eclipse Foundation across open source. I'll be keeping stuff up to date, but I'm not going to be spending a ton of time and effort to going beyond that. Now, if it's a banking application, on the other hand, I'll be spending a lot more time, resources, and effort to secure that software supply chain. Most likely, the bank will have, you know, probably multiple systems running internally to help with vulnerability management, dependency management, firewalls, whatever. Each dependency that gets pulled in will most likely go through a more rigorous process, go through proxies, go through SAST and DAST scans. Each version of each version of the software will most likely also go through some sort of third-party risk management, open source risk management, something like that. There'll be defense in depth, right? You'll have firewalls and runtime controls to also mitigate potential attack paths. And, you know, also various detective measures that if all of that is still compromised, hey, your security, you know, your SOC is going to go and get an alert that something has happened. Okay, you've done your threat model. Now what? You probably have some questions running through your head based on the previous slides, right? You probably wonder what you can get started on today that helps with your average use case. You care about security, but you're not looking to prevent progress, right? Way too many folks are, you know, I know a lot of us are in security, so we're like, who cares about the features? It's you know, the product team's responsibility. It's us to just sort of make sure stuff is secure. At the same time, it's always going to be that trade-off. You want to be safe, but you don't have the resources to, let's say, build the Linux kernel yourself, right? Maybe you do, depending on your particular company organization you work at, but a lot of folks don't have that. Most importantly, you're probably wondering how you know if any of the security changes you're making are even working. And so security, really, it's all about tracking what is happening in your systems, what's happening in your supply chains. You want to track, obviously, network traffic to determine anomalies, things like that. The same is true, right, for the software supply chain, but it's probably less mature than, you know, supply chain security. And so we want to track software as it makes its way from developer through to consumption and all the layers throughout. We want to have enough metadata about the software to be useful to determine who did what and when, so we have an idea of what to fix moving forward. Without this data being explicitly created and consumed in your systems, it's often difficult, if not impossible, to figure out what is vulnerable or compromised and what needs to be done to fix it. It also makes it much easier when you're following open specifications around this data than using something proprietary. For example, it's generally better to use open telemetry over a specific vendor's closed ecosystem, since there will usually be more support, not just in the open source, but also through other vendors in the open specification than, you know, a certain company's very specific data format. So here's some examples here, right? as opposed to proprietary software composition analysis reports, use SBOMs, right? It's just a common format, right? As opposed to just sort of dumping your logs purely to Splunk for like, let's say your build, use stuff like SLSA and use in toto attestations that are used to sort of track what's happening in SLSA. As opposed to, you know, putting your exception for a vulnerability in just something like, I don't know, an email, a ticketing system, use Vex or, you know, OpenVex. As opposed to having proprietary health metrics on every little thing, use open things like Scorecard. You know, instead of, again, I can go through each of these, but I'll just kind of go to one of the two of the other ones. Hey, as opposed to doing like building your own custom analysis for your supply chain, you can use something like GUAC, right, which is an OpenSSF tool. And then when you're doing sort of control spreadsheets for ingestion and all that sort of stuff, you know, use something like OSCAL for folks who are familiar with that, and S2C2F. And the same thing here with like, you know, don't just tightly couple your systems. You can use event-based systems to understand what are the changes happening inside of your ecosystem. What else? You know, we also have sort of runbooks and ticketing, but maybe you should use stuff like in toto layouts, which are a description of what actions are allowed to happen in your supply chain. And then as opposed to also just trusting arbitrary tools for updates, you can look at something called the update framework, which comes, or TUF, which comes from the CNCF and NYU. And that allows you to sort of essentially enforce that, yes, this update came from the right party, that yes, it came in a timely manner, that even if, let's say, somebody is preventing me from seeing an update, I can detect that somebody is preventing me from seeing an update. Quickly, the elephant in the room, SBOMs. We all love them, we all hate them, but they're here. And there's certain things that are good and bad, right? They're a rallying call for software supply chain security. They're a standardized way of communicating sort of your software supply chain metadata. They're machine readable, and support around them is growing every day, right? We're seeing a lot more tools, both in better generation as well as better consumption analysis, that sort of thing. With that said, when all you have is a hammer, everything looks like a nail. There's a lot too much focus on just throwing everything into an SBOM without really thinking about what its use is. And there's still some areas where it's too broad. SBOMs are often misunderstood, and the tooling is immature in many places. And so you end up with stuff like this, right? Where, hey, I see a bunch of JSON. What do I do with it? Sure, I could use some JQ, whatever. Maybe you start to simplify it. It starts to look like this. And I wish I could show you the full thing, but it's like that line would go down another like 5,000 lines, right? You know, with how many different packages are there. So they're complicated, right? Tools can help. You know, you can use, you know, CIF, Trivy, SPDX, CycloneDX. You know, you can look at tools like bombctl and various other things to kind of enrich your SBOMs, work with them, that sort of stuff. But few tools right now consume and store SBOMs. Now, again, in the open source, right? I know a lot of vendors have a lot of various projects, but very few open source projects really do a lot with analyzing and storing SBOMs. And it's not just SBOMs. There's a ton more supply chain metadata. You have things like in toto SLSA, OpenVex, Scorecard, OSV, all this great stuff. Okay, so what's the solution? Here's an example, right? This is the sandwich. At the top there, you have stuff that is focused on software production. So you're talking about SLSA, you're talking about Vex, you're talking about Scorecard, All-Star, Witness, things that are used to help secure the production of software. And then in the middle there, you have stuff like GUAC, Archivista, OSV, Security Insights, stuff about, hey, based on all that data now that's being generated at production time, let's pull that in, scan it, analyze it, yada, yada. You now have all this great data that about those open source projects that can then be used by consumers, right? Who can then ask questions about that software that's being built. So did it follow SLSA? If so, at what level? Is this following my internal policy? All that good stuff. So, you know, a good example here is OSV, right? You're generating a bunch of stuff, blah, blah, blah. You know, OSV has a database of all these vulnerabilities. OSV tooling can then be used to then say, yes, this thing is vulnerable. No, this thing is not vulnerable. And on the left-hand side there is, if that's the sandwich, the left-hand side is kind of like the rules for making the sandwich, right? In order to make a secure sandwich, you should be, you know, using in toto. You should be signing stuff with Sigstore or similar sorts of tools. You should be following like the baseline as an example. You know, if you're following the baseline, I feel a lot safer about that sandwich than if, you know, you're just not telling me what you're following at all. And so here's kind of maybe another look at this more from a depth perspective, right? So when you're sort of approaching open source software and building open source software, or even consuming open source software, you have a couple of different things that you're concerned with, right? The first thing is who's doing what, right? That's the trust foundation. Who do I even know is in my supply chain? Am I downloading this package from Google, you know, IBM, or is this just from a random person, right? I still, like, even if I trust the random person, I still want to know who it came from. Then you want to be able to say, okay, well, who's doing what in my supply chain and what are they actually attesting to? So the answer could be, yes, this software was written by this person and built in GitHub, right? That's useful information that if at some point in time, hey, yesterday GitHub Actions had some vulnerability and something might have been compromised. Oh, do we have information about what software was built yesterday in GitHub Actions? We're curious, you know, we're concerned about that. Well, you should start attesting to all of that stuff. And then once you've attested to all that stuff, you can aggregate and synthesize it so that you understand, hey, is this like a one-off or is this a log4j sort of situation where, oh my gosh, this is 100 applications that have this issue, right? And then finally, you can then take all of that great information and then get insight out of it, apply policy and action on that. So you can say, when I see this sort of thing happen, raise the alarm bells. When I see this sort of thing happen, remediate it in this way or prevent it in this way. So we can also tie all of this together with a tool called GUAC. For those who aren't super familiar, GUAC is an OpenSSF project. It's an incubating OpenSSF project. Pretty much what it does is it takes in lots of different supply chain security metadata, like OpenSSF Scorecard, SPDX, CycloneDX, vulnerability information, license information from things like clearly defined, deps.dev, all this great stuff to help you provide insights for sort of policy checks, patch planning, identifying critical infrastructure, all that good stuff. And so GUAC, pretty much the way that it works is we pull all this data in, we parse out all the elements of that data, so the package URLs and all sorts of other stuff, to then turn it into a graph of various facts and information. So this is sort of what a GUAC query looks like. So in this case, it's you know, it's in GraphQL. It's just essentially saying, hey, what are the dependencies of this Prometheus here? It helps you understand sort of the unknown, knowing the unknown, right? So it's about observability in your supply chain. You know, yeah, what do I know and what do I not know about the software I'm using? So as an example here, if I want to find out information about the Prometheus Golang client, we can see here there's some information about, you know, it has it currently has no vulnerability. You can see that, or at least no known vulnerability. And the source code comes from that GitHub repository. If you want to pull in information based on, like, let's say a container digest, right? You can do that as well. And here we can see that this is, or rather, this is just the hash of that software. And so as we can see here, this is for the, looks like, yeah, so this is for Kubernetes itself. Okay. You could see what software, for example, has SLSA. Yeah, so you can see what you know. This in this case, this query talks about which software has SLSA. You can ask all sorts of other stuff about license information, about vulnerability information, about patch planning as well. So you can actually ask it to give you, if you know that this thing has a vulnerability based on what's in GUAC, you can go and pull out you can go and pull out that as well. So next steps, hey, always looking for more contributors and users. There's need for more tools and integrations in the supply chain space. We're moving towards probably something that a few of us like to call the SDLC control plane or supply chain control plane. This need for managing state across your entire ecosystem of everything you're pulling in, the same way that Kubernetes orchestrates workloads. We need to have some concept, even if it's just purely an abstraction, that is, what are we pulling into our ecosystem? And, are we controlling to make sure, yes, it's being built in the right way. Yes, only approved developers are allowed to develop there, and only approved projects are allowed to be pulled into my supply chain. Well, anyway, that's what I have. And I think we have like a couple of minutes for questions. Yeah, no problem.
Hey, Mike, thanks for the talk. This was great. I love the idea of the sandwich. And I personally know GUAC is a great tool. So this is great presentation. You mentioned S2C2F a couple of times.
Yes.
And I was wondering if you could what does that stand for, and how might an organization or an enterprise use that to frame out different types of attacks, how to prevent them, align to controls? I know that's been helpful for me.
Yep.
You could call that out. I think that'd be great.
Yeah. So what's great about S2C2F is a set of rules for consuming software. So if you think about Baseline and SLSA about securely producing software, S2C2F is like essentially, what do I do to consume it? And some of it can be consume projects that look at Baseline. If those projects are not using Baseline, well, maybe what I should do is rebuild that software internally, do various scans and those sorts of things. So that's kind of where a lot of that is in there. And I would recommend checking out S2C2F, which will soon actually become part of SLSA. So you'll actually have a full sort of holistic picture in the SLSA project.
Thanks for the presentation, Mike. I am now very hungry, so I'm angry about that now. But a question, you mentioned a ton of these great tools. If I was interested in using it or want to learn more about it, what's the best way somebody could get engaged with understanding how I can use GUAC? How do I get in touch with folks and maybe contribute?
Yep. OpenSSF.org. I think that's probably the first place to go. We have a calendar. We have all sorts of stuff. There's a lot of GitHub projects. Some of the ones I already brought up today, feel free to Google them, check it all out, and come join us. There's tons of working groups. This is all open source. They're open meetings, community meetings, open maintainer meetings. Come join us, come check it out, open up issues, pull requests welcome. Just get involved. Thanks.